let us try to see now equilibrium constant. Equilibrium constant from Nernst equation. So here, while getting the equilibrium constant using the Nernst equation, there is a condition that consider a Daniell cell with a closed circuit. So what is the meaning of closed circuit? Means without salt bridge. Without salt bridge, if you take the closed circuit, means only electrodes are connected but solutions are not connected using the salt bridge. So what happens if salt bridge is removed? Automatically reactions will be stopped at a particular concentration, so that entire cell potential development will be stopped. No cell reactions takes place. So that stage is considered the equilibrium stage. So now let us see here. I'll take the rough diagram of the Daniell cell. See, imagine this type of electrodes are connected. Zinc rod in zinc sulfate, copper rod in copper sulfate. This is zinc rod, zinc sulfate solution. This is copper rod in copper sulfate solution. So no salt bridge is present. So it is not the open circuit, it is a closed circuit. Already we have seen in our previous derivations that Nernst equation, the electrode potential of this cell depends on the concentration of the electrolytes placed in the both electrolyte half cells. Higher the concentration of cathodic electrolyte, lower the concentration of anodic electrolyte, more will be the E cell value produced. So we shall take the general equation, that is E cell for Daniell cell is equals to E naught cell minus 0.059 by 2 into log concentration of Zn2 plus divided by concentration of Cu2 plus. So what happens when the cell is carried out for longer time? The concentration of Cu2 plus gradually increases. The concentration of Cu2 plus gradually decreases because copper slowly deposits on the copper rod, so that its concentration decreases. Zinc start dissolving into the zinc sulfate solution, so that its concentration value gradually increases. So this Zn2 plus and concentration gradually increases, Cu2 plus concentration gradually decreases, so which results decrease in the E cell value slowly. And this takes place for some time afterwards, when there is a stage at which no cell reactions happens. No cell reactions are taken place means no EMF of means no potential is developed. Automatically E cell value becomes 0. That stage is called the equilibrium. This equilibrium is static equilibrium, not the dynamic equilibrium. Since the reactions are not moving towards any side, that's why this equilibrium is called the static equilibrium. So at equilibrium, E cell is equals to 0, and also this particular part, concentration of Zn2 plus by concentration of Cu2 plus can be taken as equilibrium constant Kc. So let us try to apply these values there. 0 equals to E naught cell minus 0.059 by 2 into log Kc. Now you send this E cell value the other side, or else this entire part will become the positive. So that E naught cell is equals to plus 0.59 by 2 into log Kc. Or else you send now, if you want to find out the Kc value, then log Kc is equals to E naught cell into 2 divided by 0.059. And we know that E naught cell for the Daniell cell is equals to 1.1 volts. So substitute that value here. Log Kc is equals to 1.1 into 2 divided by 0.059. This value is equals to 37.288. And how to calculate Kc? Kc is equals to antilog of 37.288. So here Kc, this is the positive value. So 10 power 37, it becomes immediately 10 power value. The entire value before the decimal point will become the 10 power value. And 0.288 is there. Then how to get this value? So we have to go back to the for a few minutes and logarithms. You know that log 2 value is equals to 0.3. Now you send this log that side. So 2 equals to anti-log of 0.3. So anti-logarithms always applicable to the positive logarithms and a decimal after the decimal point. After the decimal point, 0.3 is there. So anti-log of 0.3 is equals to 2. See here, anti-log of 0.288 means this is approximately equals to 3. So anti-log of 0.3 is equals to 2. So that I can write down the 2 here. So Kc is equals to 2. Since we know the E0 cell value, we applied like this. For general equations other than Daniell cell, how to apply the E0 cell value for the equilibrium constant means, let us take this equation. E0 cell is equals to, you can take 0.059 at 298 kelvins for all cells, or else you can take the normal equation also, that is 2.303 RT by NF into log Kc. Now from this particular form, let us try to do little thing that, see here 2.303 log Kc is equals to NF E0 cell. So that you must remember this value. If you from this, if you want to get it, log Kc is equals to, let's write down this form as 2 is present. Without 2, let us write down with 298 kelvins. So E0 cell is equals to 0.059 by N into log Kc. So from this, let us get the log Kc value. Then log Kc is equals to N E0 cell divided by 0.059. So basically this formula we are going to use it in relating the Gibbs free energy with the equilibrium constant. So now let us get the Gibbs free energy and EMF of the cell. Let's try to see how these two are related. So here we know that work done formula, work done is equals to total charge exchanged to be multiplied with the potential gradient. Some potential is there. Then how to calculate the total charge? So total charge means, let us take the in terms of the number of electrons. So 1 electron charge is equals to 1 into 1.6022 into 10 power minus 19 coulombs. If 2 electrons are taken, 2 into 1.6022 into 10 power minus 19 coulombs. If 100 electrons are taken, 100 into 1.6022 into 10 power minus 19 coulombs. Similarly, n moles of electrons are taken, then n into 1.6022 into 10 power minus 19 coulombs. You must remember that 1 mole of electrons if you take, that means 1 mole. 1 mole means 6.022 into 10 power 23 into 1.6022 into 10 power minus 19 coulombs, whose value is equals 96,500 coulombs, which is known as the 1 Faraday. So in this case, we are mentioning that n moles of electrons. That means n mole of electrons charge is equals 96,500. That is known as the 1 farad. So NF. So if 1 mole of electrons means 1F, if 2 moles of electrons means 2F, 3 moles of electrons means 3F. So total charge transferred in a particular electrochemical cell, let us take as the NF. N moles of electrons are exchanged. Their charge is equals to NF. Potential, let us take E. So that work done is equals to NF E cell. But work done is always measured using the Gibbs free energy. That means how work is done. If some energy is available with a particular body, that will use that energy to do the work. So the available energy, if it is more work will be done. If available energy is less work will be done. So available energy in a particular body is known as the Gibbs free energy. And moreover, so that here work done can be written as Gibbs free energy. Since electrochemical cell is a spontaneous reaction, this Gibbs free energy we take as negative. So that here in the place of work done, we are going to write down the delta Rg. Rg means in a particular reaction, Gibbs free energy change is equals to NF E cell, or else delta Rg is equals to minus NF E cell. So like this we can calculate. And here E cell value is an intensive property, whereas delta G value is an extensive property. If the stoichiometry coefficient changes, if a reaction is multiplied or divided with a factor, then delta Rg value changes, but E cell value do not change. Now let us take an equation. So here zinc plus Cu2 plus gives Zn2 plus Cu. Its E0 cell value is equals to 1.1 volts. But delta Rg value, delta Rg is equals to number of moles of electrons. 2 moles of electrons minus 2F E cell. E0 cell values don't change, or else E cell values don't change. Here, next, if the reaction is multiplied with a factor 2 zinc, 2 Cu2 plus gives 2 Zn2 plus 2 Cu. So again E0 cell value no change, 1.1 volts. But delta Rg value is equals to minus 4F E cell value. That's why we have taken delta Rg value as an extensive property. Now let's come to the point that if all concentrations of electrolytes taken as unity, all concentrations of electrolyte taken as unity, then E cell becomes E0 cell. Then in the place of E cell we can write down E0 cell means standard conditions at 298 kelvins. Then automatically this becomes the delta Rg0. So we can write down delta Rg0 is equals to minus NF E0 cell. Now here is if condition, if E0 cell is equals to positive, then delta Rg0 is equals to negative. Such a process is known as exergonic. Second, if E0 cell is equals to negative, delta Rg0 equals to positive, they are known as endergonic. So what is the purpose of using these different terms instead of exothermic and endothermic? We are using the exergonic and endergonic. Exothermic, if heat is released completely, that is called as exothermic. Endothermic means it is absorbed. Here no heat is released or absorbed. All electrons are moving and that electrical energy, that chemical energy we are converting into the electrical energy. but still it is spontaneous reaction. So here electrical energy is produced from the heat that is going to release, but actually heat is not lost. There is no release of heat energy is present. Heat energy is completely been converted into the electrical energy there. So that's why it is called as exothermic reactions are slowly changes to the exergonic, means delta Rg naught is equals to negative. If it is absorbed, then it is known as the endergonic reactions. Now here, from this we can write down one more format, that send the negative value this side. So NF E naught cell is equals to minus delta G naught. Now E naught cell is equals to minus delta G naught by NF. So this formula also we can use it. Now let us see how to relate the Gibbs free energy equations, calculation of the relation between the standard electrode potential of the half cell for a different metal in the different oxidation state. A relation between standard electrode potential of half cell with a metal in different oxidation state. In this particular part, we are going to discuss the when two electrodes are asked and given and asking about the third electrode, that electrode potential may not be available, but we have to calculate it. So in such cases, by joining these two electrodes or by subtracting these two electrodes, direct their potentials is not possible. Why? Because delta G naught, that means Gibbs free energy is an extensive property, and moreover it is an additive property, whereas electrode potentials are not additive properties. So that's why we cannot add and subtract the electrode potentials directly, but we can do only with the delta G naught values. So let us take here delta G naught 3 is equals to, we can write down delta G naught 1 plus delta G naught 2. So by adding two delta G naught values, we can get the third delta G naught value. Delta G naught means we know that minus NF E naught. So let's write down N3F E naught 3. Number of moles of electrons in third equation, Faraday is constant. Third equation, electrode potential. Minus N1F E naught 1 minus N2F E naught 2. So minus and F values cancel out, so that N3 E naught 3 is equals to N1 E naught 1 plus N2 E naught 2, and E naught 3 is equals to N1 E naught 1 plus N2 E naught 2 divided by N3. Let us try to see how to use this equation by taking an example. So example is, given that E naught MnO4 by Mn2 plus is given as 1.51 volts, its E naught value, and E naught of MnO2 by Mn2 plus is given as 1.23 volts, and they are asking E naught of MnO4 divided by MnO2 could be how much. So when the equations are given like this, we cannot add and subtract the E naught values directly, and moreover we have to construct a redox reaction from higher oxidation value to the lower oxidation value, so that the sequence of reactions will happen. So basically in both of these equations, the product is Mn2 plus, and here MnO4 minus. they're asking to get the MnO2. So let's write down MnO2. MnO2 again changes to the Mn2 plus. So here we got the all reactants and products. MnO4 to Mn2 plus also possible. Here manganese oxidation state +7, here it is +4, here it is +2. So in the decreasing order I have written. So I am considering this entire equation from here to here as a single step and overall reaction, so that this I am taking delta Z03. This is I am taking as a delta Z01 first step. This I am taking as a delta Z02 second step. So they asked us to calculate delta Z01 by giving these two values. So that I am going to write down delta Z03 is equals to delta Z01 plus delta Z02. Delta Z0, I want the delta Z01 because MnO4 to Mn2, that MnO2, that is only asked. Delta Z01 is equals to delta Z03 minus delta Z02. Now let us try to put this substitute their values minus NFE. So minus N1F E01 is equals to minus N3F E03. Minus into minus becomes plus here. So that N2F E02. Now send this minus that side. So it becomes plus. This becomes minus. Faraday's cancel out. So that I can write on N1 E01 is equals to N3 E03 minus N2 E02. Now send the E01 N1 value that side. So that E01 is equals to N3 E03 minus N2 E02 divided by N1. So let us substitute those values. E01. E01 means that our meaning is MnO4 minus to the MnO2. So here MnO4 minus to MnO2 is equals to N3. N3 means in this overall reaction how many number of electrons are exchanged. +7 +2. So 5 moles of electrons are exchanged. 5 into its E03 value. So this value is given as 1.51 minus N2. So in this reaction +4 +2. So 3 moles of electrons are exchanged. So 3 into E02 MnO2 to Mn2 plus MnO2 to Mn2 plus 1.23 volts. N1 means this particular case. So +7 to the +4. So here 3 moles of electrons exchanged. +4 to +2, 2 moles of electrons exchanged. Sorry, here. So we get the answer by solving this. So you put the answer in the comment box. So like this we can solve the questions, and I will give you one more question. Imagine Cu E0 of Cu2 plus by Cu plus is given as X volts. E0 of Cu plus by Cu is given as Y volts, and they are asking what is E0 of Cu2 plus to Cu. So let's write down the equation here. Cu2 plus changes to the Cu plus changes to the Cu, and Cu plus to the Cu that they are asking, this is the question mark, that is delta G03, and this is delta G01, this is delta G02. So here is delta G03 is equals to delta G01 plus delta G02. This is equals to, already formula is given, delta G03 means E03 is equals to N1 E01 plus N2 E02 divided by N3. And let us try to apply those formulas here. So I am taking here E03 is equals to N1, first step, 1 electron, and its potential E01 Cu2 plus to Cu, X volts. So that it is 1 into X volts, so that X plus is there. N2 means second step, Here also only one electron change is there, plus 1 to 0, 1 difference. E2 value, Cu plus 2 Cu, Y volts are given. So this is equals to Y volts divided by N3. N3 means in this reaction total number of electrons, plus 2 to the 0, that means 2 is the difference, so that we can write down that 2. So X plus Y by 2 volts. So this is the way to calculate the unknown electrode potential using the delta G0 3 is equals to delta G0 1 plus delta G0 2 formula. So dear students, I hope you understand today's class, and we shall meet in the next class. Thank you one and all.